Hi again, it's Pedro from Tuist, and I'm bringing you a new video about Tuist and about some features of the tool. Today in particular, I would like to share with you how dependencies work in Tuist. When I started building Tuist, I was a bit fed up about the way you define dependencies in Xcode. It is fine if you have a small project, like common, one target with an app, maybe a framework, so that you can share code between the app and the extension, third-party dependencies using CocoaPods or using Carthage or Swift Package Manager. The thing is that when you grow your app, you would like to benefit as much as possible from incremental builds. And this is something that you can benefit even more if you modularize your code base. You've probably seen a lot of companies talking about, I'm modularizing my code base and this is how I'm doing the modularization. This is something important when you grow your project, your team, not just because of the incremental builds, also because it allows you to define different business domains in code. You can define boundaries, and that helps us have a better architected code. What I didn't like about Xcode is that, like, when the dependencies, the local dependency tree is small, it's fine, you can do it, you can add the build settings and the build phases yourself. But as things grow, it becomes harder and harder to do things right. You might need to add a dynamic dependency somewhere in the dependency tree, and then that might require changes in other nodes of the dependency graph. For example, you might need to copy that dependency into an app target, you might need to copy that dependency into a test bundle. This is something that, in order to do it properly, you have to know the dependency graph, you have to keep it in your mind, and unless you have been architecting the project all the time, you don't really know. What I've seen that translate into in companies is people trying to add new frameworks, people trying to add new projects, and that resulting in framework not found. My app doesn't compile on CI. The compiler fails, and I don't know why. And this is a place where you don't want to be as a company. So what I'm gonna show you here is how we solve that with Tuist. So I'm gonna start by creating a new directory. I will call it my app, and I'll sit into my app, and I will open this with Visual Studio Code. And I will create, I don't know if this opened properly. Let's go back. Code. Yeah, for some reason it's not opening. Anyways, forget about that. What I will do is I will create a new project.swift file. This is the file that contains the project. After creating the file, I can do twist edit. Let me close Xcode because when we regenerate the project, like in this case, and the project was open before, Xcode doesn't know how to reload things. It's the same with the Swift Package Manager. Sometimes it complains that things change in disk and it doesn't know how to reload. So I get my project here, my project.swift. I can import the project description, which is the framework that contains all the definitions of the models that I need for defining projects. And then I will do let project equal project. And the good thing about using Tuist and its TSL is that you can edit things with Xcode, and you get auto-completion, you get auto-completion, you get documentation, and you also get validation of the things that you do, which is very handy when you're editing a lot of projects. So I will call my project my app. I won't pass the organization name, which means it will take a default value. We'll define packages later. I won't pass settings either because I will take a default value. Targets is empty for now. no schemes, which means it will take default schemes and no additional files. Then I will define a target, which is going to be the app. The name is going to be my app. The platform is going to be iOS. The product is going to be an app. Product name, I won't pass it because it will take the default value. The bundle ID, I want it to be io.tuist.myapp. Same with deployment target, it will take default value. With info plist, I will tell Tuist to take default values. Regarding sources, I'll say everything that is under sources with a Swift extension, not resources to keep things simple. The same with headers, the same with entitlement, the same with actions, dependencies. Well, dependencies I will leave it empty because this is the one that we want to play with. This example, no settings, means it will take the default, no core data, no environment. Before I generate anything, I would like to create a source file so that at least we can see if the app compiles. So what I have here is an example of an app delegate. I will just copy and paste it. So I'll go back to my app. I will create the. Actually, I said in the project that all the sources of the app are gonna be under sources, whatever. I'll say they're under sources my app, and everything that is Swift under my app is gonna be added. So I'll go back. I'll do make directory sources, and then here I will create my app, and in my app I will add the app delegate.swift, and I will paste everything. In this case, I won't create. Oh well, we can create it like an empty UI controller with a background color, and then everything should work. So I close this, and then I can go back to the root. If we did things well, and I run Tuist generate or Tuist focus, which is the same as generate, but it opens the project, I should get an app so that I can compile. You see, I have my app, the project, I have a target, which is the app, with the bundle ID that we specify with the name, and everything is fine. If everything goes well, I should be able to compile this. I will clean first, and then I hit build. It failed. Because in the example that I copied, I was importing something that doesn't exist. So I delete this one, and it compiles. So let's start adding dependencies. So I will close the project for now, and I will go back to this file. So let's add a second target, and I will call this one. Actually, let's copy the whole thing. It will be easier. So I copy this one. I hope, yeah, everything was copied properly. So let's call this framework A. This is gonna be for iOS. The product is gonna be a library, in this case, a static library. The name is gonna be, the bundle ID is gonna be io.tuist.a, then default, and then the sources are gonna be under A. So I'll try to open this with Visual Studio Code. Should be faster if Visual Studio Code is happy with. Well, I'll try manually. So my app, sources, or yes, my app. Let's see what happens. Nothing. It's good. Visual Studio Code is not happy today. So I'll try to close it and then try to open it again. I guess this happens when you do live videos. Nice, I have it open now. So I have it here. And then I'm gonna go to sources. I'll create a new directory. I will call it A. And inside A, I will create a new file and I will call it a.swift. I import foundation. And then I do public class A public init. And that's all I will have here. So if that goes well, I should be able to do import A. And here I should be able to do let a equal, and then I initialize the variable, the class a. So going back to Xcode, there's one thing missing here, which is defining the dependency. And this is something that I was talking about at the beginning, that Tuist makes it super, super easy. So if we go to my app, I have dependencies as an attribute. And here I can say I have a dependency with a target that is part of the same project. And the target is the target A. So as you can see, no build settings, no build phases, nothing, just plain terms. I depend on target A. And this is the part that is the most beautiful of this API. So I go back to the terminal and then I do Tuist focus. And let's see what I get. So I open the project and then I see that I have an app and I have the library with the sources in it. And I should be able to compile the app if everything went well. Boom, and it works. I can actually go to the app delegate, and then I can see that I can import A and I can use A properly. So I will close the project and I will go back to this one. Let's keep making this one complex, more complex. So let's say we have another framework and we call it B. B is going to be a framework in this case for iOS. The sources are going to be under V, and then in this case we are going to have a dependency between A and B. So this is how I put the dependency. The only thing that is missing is creating the file. So I'll create a folder, B. I will add a new file called b.swift. I'll copy everything from A into B and rename B. And to make sure this works, on A, I'm gonna do import B, and I will say B, I'll make this a bit bigger, B, like this. So I'll go back to let's double check that everything is fine. So B is part of B, and I use it from A, importing B. So let's do Tuist focus. I get the project, I see the targets, everything is fine. I have my app, I have the static library, I have the framework. I can try to compile my app. And the important piece here is that A as a static library will end up being part of the binary of the app, and B is dynamic, so that means it should be copied into the app. So how do we know if the framework was copied? We can take a look at the build phases if you want to, but we can also go to the product. We can go to the app, we can show it in Finder, we can see the packages, like the app, we can see the frameworks folder, and yeah, it was copied. So if I try to run the app in the simulator, everything should work. The linker should be able to find the... Cool, let's keep making this more complex. So let's say that at this point I would like to add a Carthage dependency. For example, RxSwift. So somewhere in the documentation it explains how to add the dependency. So I'm just gonna create the cart file. I'll paste the content and I'll do Carthage update platform iOS. I think that's the syntax. So let's see if this works. Yep, so it's cloning RxSwift. And it should, it's downloading the binary from the release. So in the meantime, I'm gonna go back to my project definition. I will go to B, for instance, and I will say that this one has a new dependency. And one of the dependencies that we can define is a dependency with a framework where we specify the path. So we are gonna say, in this case, the framework is RxSwift, which is under Carthage build. I'm not sure if this is right, but I will check later. iOS, and then RxSwift.framework. It's trying to build a scheme, so let's see if the path is right. we open Carthage, the directory, and then we see that, yeah, it's still building. So it's gonna take a while. So in the meantime, I'm gonna leave this one in the background. I will comment this one out, and I will define dependencies with packages, which is another interesting bit. So as you can see, I can specify the packages that this project depend on. So I can say I have a new package, which is remote. In this case, I'm gonna add Alamofire. So yeah, this will be the URL of the project, and then the requirement is going to be, this is very similar to how Swift Package Manager does it, so I can do up to next major, and we can use the same example as in the README, so this one. So with this, we say that our project has a dependency with the package, but we need to specify from which target we would like to link Alamofire. So I'm going to do it from this static library. So here I can say I have a dependency with a package where I say that the product is Alamofire. And if everything is fine, yeah, this code is happy with my manifest. I just make sure that the indentation is right, although this is not right, but everything should work. I'll go back to the terminal. In the meantime, Carthage is still building things, so we'll leave it there. So we can do Tuist focus again. And look at how Tuist is smart enough to say, oh, you have now a dependency with the Swift Package Manager. Let's resolve the dependencies so that we can generate the log file, and we can put it in the root so that any user that is trying to generate the project again will take the same dependencies as you. So now we see this new dependency, Alamofire here, as you can see. If we go to A, yeah, we see the dependency with Alamofire, everything is fine, and if we try to compile my app, it's actually compiling Alamofire because it detected that it's a dependency of A, and after it finishes compiling Alamofire, it will compile A and then the app. So we can go to A and see if we can import Alamofire. Boom! And it works. So let's see if we can, if there are some examples of the API so that we can use. Installation usage, just to make sure that it works. So we can try this example, for example. We'll try to compile, and it works. So far we have app depending on A, static library, A depending on B, dynamic library, and A also depending on the Alamofire package. As you can see, everything is defined without talking about build phases or talking about build settings. That is inferred automatically. And the graph is also very explicit, because if you read this target, you can see that there is this dependency. And if you read this target, you can also see that the dependencies of the target. So let's finish this video with the last example, which is the Carthage. If everything went fine, hopefully now it's trying to compile Rx Swift. So let's see if we have something. Yeah, we have a build directory, we have iOS, and still compiling the other frameworks, so hopefully we'll finish soon. We can try, Rx plugin seems to be there, so let's try to define the dependency. So I don't know if this is going to work because it probably depends on Rx Swift. So if I do Rx plugin, yeah. So this won't probably compile, but let's see. So I'll go back to the terminal. I'll do Tuist focus. And let's see. So B has now a dependency with Rx blocking, and my app is embedding the frameworks, both B because it's dynamic and also Rx blocking because it's also dynamic. Carthage frameworks are dynamic, as you can see here. We are also copying the Rx blocking, stripping the architecture so that we don't need. If we compile the app, it works. So let's see if from B we are able to import Rx blocking and it doesn't complain. Boom, and it works. So, and now we have Rx Swift, so we can, I'll close the project, I'll go back to here, and I will say instead of Rx blocking, it's gonna be Rx Swift, and I can do again Tuist focus, and I get my project again. I can go to Beetle Swift, I'll do Rx Swift because it's the one that I want, and I can try to do create an observable. I will do nothing, return disposables. And I try to compile everything and it works. Or maybe I'm speaking too fast, but it should work. You can see that for every target that we define, we get a scheme, so that that way we don't have to compile everything together. We can compile targets individually. And I just had an idea. I will add an extra target which contains the tests of the app. So I'll close the project again. I'll go back here, I'll copy my app, I will add my app again, I will change my app to be my app tests. This is gonna be unit tests. The bundle ID is gonna be my app tests. Info plist will take the default. The test will be under tests, my app, and then whatever is Swift. And then I have a dependency with, in this case, my app. This means I'm writing the test for this app which I depend on. So I will create the tests directory, and this is my app test, we can call it, or just my app, because test is in the name of the folder that is part of. So I'll do my app. Here I'll do my app test.swift. I'll say import foundation, import xc test, and then I'll create a test. My app test xc test case. So if everything is properly defined, I should be able to get the tests bundle. So if I do Tuist focus, I get the project where you can see there is a new tests bundle, which I can try to compile. Yeah, actually the import is wrong, so it complains about it. You can see that it detects this one as a test. And there's some, like an important thing to mention, which is, this is my app. Actually, everything is fine. So yeah, I get everything created. My B depends on Rx Swift, A depends on B, then my app tests depends on my app, and my app depends on A, and everything compiles. As I've been doing, you can do this with as many targets as you want. What Tuist does internally is defining a dependency tree. It understands how things depend on each other, and then it translates that from those plain terms to build settings on build phases. And this is super handy. And when you are scaling, when you are growing your app, where you are probably adding, removing, renaming dependencies all the time, you don't want to be thinking in terms of build settings and build phases. And Tuist makes it super easy. So in the following video, I would like to show you how we can leverage the idea of having a graph, a dependency graph, to visualize the graph, to get an image that shows you how things depend on each other. But that's part of another video. I hope you like this one.